In lesson 4.2, there are two primary objectives. One is to convert degree measures of angles to radian measures, and vice versa. If we're given a radian angle measurement of an angle, convert it back into degrees. So part of it is going to be studying the radian measurement, how do we measure angles using radians, and then converting radians to degrees and degrees to radians. The second part is to use those angle measurements to solve real-world problems. And degrees are fine for some trig functions. They're really good to use degrees. That's where we see most of our applications there. But once we get outside of the trig applications, we see that radian angle measures are a little bit more convenient in solving real-world problems. So there's a purpose for using those radians. They're just easier for us to use mathematically, and they have more connections to the applications. So the first thing we'll do is we'll talk about angles and degree angle measurements. We won't really get into radians on this first slide at all. Just a quick review of some information about angles. Angles are always going to be set up with two rays connected at a common point called the vertex. So our vertex is where the two rays intersect. It creates an angle by rotating one side from the initial side to the terminal side, the finished side. So we have our initial side where we start our angle measurement, and we rotate counterclockwise typically to get to our terminal side that creates the angle. If we were to place this on the coordinate axes, what we end up having is an angle in standard position. So they will be talking about an angle in standard position quite frequently. What it means is the vertex must be on the origin, the initial side must be on the positive x-axis, and then in order to get our angle, we have to rotate. Typically we go counterclockwise, and we call that a positive angle relationship, and it's going to go until we hit our terminal side. So our initial side will always start, again, re-emphasizing, it will always start on the positive x-axis. We will rotate a certain measurement in degrees to get to our terminal side. If we go positive, it'll go counterclockwise, and that's what they're getting at on this diagram. Positive angles always go from the positive x-axis, and we rotate counterclockwise to our terminal side. So that's if we measure an angle in a positive direction. If we measure an angle in a negative direction, we still will always start, initial side is always going to start on the positive x-axis, but in a negative angle, we rotate clockwise to get to our terminal side. So we do have the option of measuring angles in a positive direction or a negative direction. We just have to see what our application or what we're asked to do with that. The next thing we do is to review a little bit of our circle, and the concept that we know is that in one complete rotation around a circle, thanks to the Babylonians, we now know that is 360 degrees. So one revolution or rotation around a circle equals 360 degrees. Okay, so then if we start looking at the other ways that we can break this down, then a half of a revolution or a half of a rotation, I don't care which way you think of it, is equal to 180 degrees. A quarter of a revolution or rotation is equal to 90 degrees, and you can break down this circle a lot of different ways, but then they went to a 45. 45 is an eighth of a revolution. If we go to a 60-degree angle, a 60-degree angle is basically 1/6, so that is 1/6 of a revolution is 60 degrees. And they broke it down into 30s, and 30s would be, if you think about 30 out of 360 degrees, that is 1/12 of a revolution. So 30 degrees. So nothing new here, just kind of re-emphasizing, reiterating that we can break down the circle in a lot of different ways. A connection here is the revolutions and rotations back to the degrees. So nothing real earth-shattering here. What we're going to work on and practice in the first example is converting decimal degrees. When they say a decimal degree, it's going to look like this. We're going to convert that into a degree, minute, second. So we're going to take this and convert it into something that looks like this, where you'll see latitude and longitude a lot of times written this way. And then we're going to go the other way. We're going to be given something in degrees, minutes, seconds, which they call DMS form, and we're going to change it back into just a decimal form. So our first task is to change between degree decimals, or decimal degrees, and degrees, minutes, seconds. So a little side note here about the Babylonians, and then something you can use your calculator with as well, but the point of emphasis on this would be to use, not to use your DMS form on your calculator to convert between angles and degree decimals, but what I want to see you guys do is take this 213.875 degree angle measurement, and we're going to convert it into degrees, minutes, seconds. Now what we do is we break this up into, we know we have 213 degrees that are complete, but we also have an additional 875 thousandths of a degree. But we want to convert this into minutes and seconds. So I'm going to leave the 213 degrees alone, plus, now we need 875 thousandths of a degree. We're going to use or utilize some unit multipliers to help us make these conversions, because if we use unit multipliers, it helps us keep track of our units. So we know in 1 degree there are 60 minutes. So when we do this, we are going to get our degree measurements to cancel, and we're going to be left with whatever 0.875 times 60 is. So we got 875 thousandths of 60 minutes. So I've done that calculation already on the calculator. Is 0.875 times 60. That gives us a remaining 52.5 minutes. So we have 213 degrees plus another 52.5 minutes. Now we have it in degrees and minutes, but we want to convert this into degrees, minutes, seconds. So we know we have our 213 degrees, plus we have another 52 complete minutes, then we have another half of a minute. Well, this is fairly easy. A half of a minute should be 30 seconds. But if I use these unit multipliers, in 1 minute there are 60 seconds. So then we reduce our units of minutes, and we're left with half of 60 seconds, which would be our 30. So when they write this all out, they can just go 213 degrees, 52 minutes, and 30 seconds is how we convert that decimal degree or degree decimal degree form into a degrees, minutes, second. Okay, so the second example goes the other way. So I'm going to clear that off. And we're going to take our 89 degrees and plus our 56 minutes, and then plus our 7 seconds. And we're going to go just to degrees. So we want decimal degrees on this one, so I want to keep my degree marks. And I want to change 56 minutes into degrees, so that's going to be plus 56 degrees. I want to take it times a unit multiplier. In this case, I want the degrees, I want the minutes to cancel, so I want to put 1 degree is equal to or equivalent to 60 minutes. And then I put the second, 60 minutes. So now the minutes units will cancel, so we'll take 56 divided by 60, and that'll give us what part of a degree that we have. So it's going to be 59 degrees plus whatever we get from that calculation. And then I'm going to continue on over here. We got 7 seconds. So I want to get rid of the seconds. So I want to multiply by a unit multiplier. Well, I want to make sure seconds go on the bottom. And I want to convert it to degrees. So in 1 degree, there's 60 minutes in a degree, and there are 60 seconds in a minute. So that means there are 3,600 seconds in a minute, just like on the clock that we do. So we have 3,600 seconds in a minute. So what we're going to have to do is some quick calculations here, and then place those in so that we can write it in our decimal degree. So first one will be, I got to take 56, and I got to divide it by 60, and that means we have 0.933, so plus 0.933, and it's repeating, plus, and then we want to take our 7 seconds and divide it by. So this is going to be better if I do this all in one stream here, so I'm going to do the calculation and come back and do it a different way so I get it all together. So that's 7 divided by 3,600, and that's going to give us another 0.00194. So I can be more accurate with this. It's better if we were to calculate this all in one string. So I want the 89 plus, then we want 56 divided by 60, then we want plus, we want our 7 divided by 3,600. And what we get for, and I think we're supposed to round the nearest thousand, is 89.935. So 89.935 is our approximate answer for our decimal degrees. So conversions, degrees, minutes, seconds to decimal degree, and vice versa.